Hi, good evening to one and all. This is faculty of ACE Engineering Academy. We welcome you all for the feedback session and analysis on today's GATE mechanical engineering question paper. My dear friends, the paper what we have seen is slightly moderate. It's not tough. It is what it is being taught in regular classroom. The senior faculty of mechanical engineering is over here. And we wish everyone, those who have passed through ACE Academy, all the best. Bang that, All India rank 1. I wish you get to that particular point. If you see the today's paper analysis, is out. It is thermal engineering. If you observe, it's very easy paper. Though we were getting, mixed opinions. All the faculty is over here. Madhushekar sir is here. Yeah. So I'll try to ask Madhushekar sir to express his thought on this particular paper.
Yeah. See, actually, from the production, the questions are moderate. And from the material science, question is very easy. One question, they asked 2 more question, that is actually density question. From the production, the questions are moderate.
Yeah, coming to design, guys, the questions are easy to moderate. Almost 60 to 70% questions are easy level. Hardly 1 or 2 questions are little tough they have given, guys. But if you attend our regular classes, you are able to solve all the questions from the design. Okay, now, yeah.
Hi students, based on the questions given by the students, memory based questions, 5 questions asked from thermal engineering. All questions are very easy questions. All questions discussed in the classroom. Total 10 marks asked from thermal science. Okay.
Hello all. So I see that we have got 3 questions from machine design, 1 from springs, 1 from design, and that is from joints. So all the 3 questions are considered to be very easy. I guess you have solved these 3 questions from design. I wish you all the best. And let's see the weighted, the solutions for the memory based questions here.
Thank you, Dharan. Aptitude.
Hi all. From the general aptitude, easy to moderate level questions, not a difficult, okay, not a time taken, easily are able to solve. I hope each and everybody also getting good score in the aptitude. Thank you. All the best.
Mathematics, Venkatreddy sir.
Good evening to all. What are the questions are given from the mathematics part? All are the moderate, not difficult level. So easily we can solve the all the answers.
There's a small disclaimer. The disclaimer is all these particular questions have been obtained through a telephonic discussion from our students, those who have written it. And then it's mostly accurate, but all for same. As it is the initial vanilla cut of the exam, we have this particular disclaimer, but the analysis goes like this. So if you look at the analysis, So friends, if you look at the analysis is like this. Specific analysis made from, ACE Academy. If you look at it, production technology, 12 marks. Thermal engineering, 10 marks. Heat transfer, 7 marks. Fluid mechanics and turbo machinery, 7 marks. Theory of machines, 9 marks. Strength of materials, 10. Machine design, 3. IM and OR, industrial management and operations research, you have 10 marks. Engineering mechanics, 2 marks. Engineering materials, 2 marks. Engineering mathematics, 13 marks. And general aptitude is 15, totally coming out to, 100. And if you look at the questions, numerical aptitude, you have around 19 numerical based. Then multiple choice questions are 46. And multiple select questions with more than one answer is no. If you look at this particular paper pattern, when we are getting a feedback of students telling that it's slightly moderate to tough, and options of easy is okay here and there, you have a very bright chance of getting very good ranks through ACE Academy. So I would like to take up this particular session. The next material science will be taken up by Madhushekar sir.
Right. Hello, good evening, friends. So from the material science, they asked a question from the theoretical density. As per the student given data, they said that the question is from FCC structure. Question is from FCC structure. The given data here it is. Given data here it is. Density is given. Density is given 2.71 grams per centimeter cube, and atomic weight is given 26.98 grams per mole. Atomic weight 26.98 grams per mole, and Avogadro's number is given, that is 6.023 into 10 power 23. This is the data given. From this data, they are asking atomic radius. Okay, atomic radius they are asking. Atomic radius they are asking. Okay, na? Now, first of all, theoretical density rho is equal to effective number of atoms into atomic weight by Avogadro's number into volume of unit cell. This is the formula actually. Now here it is a face centered cubic structure. Okay, na? FCC structure. For FCC structure, effective number of atoms are 4, and 4R is equal to root 2A. R and A relation. You should remember this value. Right. From this, A is equal to 2 root 2R. Then volume of unit cell A cube is equal to 2 root 2R whole cube. That is 16 root 2R. Now I am going to substitute in this equation. So in the equation, in this density is given 2.71 grams per centimeter cube. I am not changing the units. I want in centimeter only. That is equal to number of atoms 4 into atomic weight is 26.98 by Avogadro's number 6.023 into 10 power 23 into volume of unit cell 16 root 2 R. 16 root 2 R cube. 16 root 2 R cube. Right. So by using calculator, if you solve this equation, you will get the R value nearly 1.429 angstroms. This is the final answer. Okay. R value is 1.429 angstroms. This is the question, 2-mark question asked from this theoretical density formula. Right. Now, next another question from the production, especially from the sheet metal operation they asked, especially from the deep drawing. Okay. From the deep drawing they asked. From the deep drawing, this question is also a 2-mark question. Deep drawing. So what is given? In a deep drawing operation of a rectangular sheet metal, 30% stretching in length. Remember, rectangular sheet, it is given rectangular sheet, okay, 30% stretch in length, 30% stretch. 30% stretch in length means length is increasing. Stretch in length is increasing. 15% reduction in thickness. 15% reduction in thickness. 15% reduction in thickness. So thickness is decreasing, length is increasing. Assume volume is constant. So in the question, volumetric change is constant. So in the question it is given clearly. Right. So they are asking normal anisotropy of the material they are asking. Okay. Volume is constant and normal anisotropy they are asking. So normal anisotropy is the ratio of a true strain in width direction to the true strain in thickness direction. Okay. Now we don't know the true strain in width direction, so we need that. So because of change in volume equal to 0, from this we can write, okay, true strain in length direction plus true strain in thickness direction plus true strain in width direction is equal to 0. So from this, true strain in width direction is equal to minus true strain in length direction minus true strain in thickness direction. So I can write here true strain in length is equal to ln. So 30% is increasing. 100 plus 30, 130, right? So I can write 1.3 minus true strain in thickness. Thickness is reducing 15%. So 100 minus 15, 85. So 0.85. Okay, na? So from this equation you will get the true strain in width direction. So the true strain in width direction is nearly minus 0.099, right? And true strain in thickness direction is minus, you can take it as, sorry, no need to take a minus, directly you will get minus ln 0.85, you will get minus 0.165. Okay, now the ratio if I take R is equal to, okay, R is equal to minus 0.099 by minus 0.165, so that here answer is 0.60. Okay, this is the question from the deep drawing. And one more question I am going to discuss from the Iamond ore. Actually the Baldra sir have some fever, that's why I am going to discuss, that is actually from the linear programming. So what is the given data here, you know? Given data. So given data is given here, minimize z equal to 0.07 x1 plus 0.05 x2 and 0.1 x1 greater than or equal to 0.4, 0.1 x2 greater than or equal to 0.6, 0.1 x1 plus 0.2 x2 greater than or equal to 2.0, right? 0.2 x1 plus 0.1 x2 greater than or equal to 1.8. This is the question given. So this question we are solving from the dual model. This is the question we are solving from the dual model. In this case, I am writing here 0.1 x1 plus, okay, 0 x2 greater than or equal to 0.4. This I am assuming it as a K1. Okay. The next one, 0x1, because here it is not there x1, 0x1 plus 0.1 x2 greater than or equal to 0.6. This is equation K2. Okay. And third one, 0.1 x1 plus 0.2 x2. Two data given, that is greater than or equal to 2.0. I am assuming it as a K3. Okay. Now again one more, 0.2 x1 plus 0.1 x2. Okay, 0.1 x2 greater than or equal to 1.8. I am assuming it as a K4. Now here I will consider the x1 data separately and x2 data separately. Let us consider x1 data, 0.1 x1. Okay, you can take 0.1 K1. Okay, 0 K2, you can take it as a K2 is 0. We are not taking directly 0.1 K3 and 0.2 K3. Directly I am writing here. Equation I am writing directly. Now you can take here 0.4 K1 plus 0.6 K2 plus 2.0 K3 plus 1.8 K4. Right. And from this you can take it as 0.1 K1 plus 0.1 K3, because K2 is not there. Directly K2 is x1 equal to 0. That's why. And plus 0.2 K4 less than or equal to 0.07. See here, less than or equal to 0.07. Next, one more equation, 0.1 K2 plus 0.2 K3 plus 0.1 K4 less than or equal to 0.05. See, by solving these equations, okay, you will get to know that K1, K2, K3 all are greater than or equal to 0. So this is the final solution. So till now we got this many questions from these subjects. In case if we get any question from the production, we will update. Next, our colleague faculty member Dharan Sai sir will continue.
We have got 3 questions from design. Let's see the first question, which was asked from static loading. He gave that the value of sigma x is given as sigma. The value of sigma y is given as minus 2 times sigma. And the value of SY it is given as 550 megapascal. Factor of safety is given as 2. He's asking us to consider distortion energy theory to find the value of sigma. Okay, so which theory he's asking us to use? Distortion energy theory. So here you can notice that if the value of tau xy is not given, as tau xy is considered to be equal to 0, okay, as it is not given, we can consider the von Mises stress equation as sigma von Mises is equal to, we can consider sigma x to be equal to sigma 1 and this to be equal to sigma 2. So where sigma 1 Mises equation in terms of sigma 1 sigma 2 can be written as sigma 1 square minus sigma 1 sigma 2 plus sigma 2 square. And we know that according to distortion energy theory, this value has to be kept below SYT divided by factor of safety. Okay, so if I substitute the value of sigma 1 and sigma 2, where sigma is common here, okay, as sigma is common, so let me take it out, under root 1 square minus 1 into minus 2 plus minus 2 square. This is lesser than or equal to 550 divided by factor of safety whose magnitude is given as 2. So from here, we can notice that the value of sigma comes out to be lesser than or equal to 103.94 megapascal. Very simple question. It was asked from static loading. Now moving to the next question, which is asked from springs. Let's see the next one. So he's asking us to identify what is the maximum shear stress developed in the wire. Okay. So we know that the equation for tau max in case of springs. So considering the possibility of direct shear, it is Ks into 8fd divided by pi d cube. Okay, and we also know that see, this is only when we are considering the effects of direct shear. So we know that Ks is 1 plus 1 by 2c, okay, into 8fd divided by pi d cube. Okay, so unlike this, we can also write this in a different format. We know that the spring wire under compression is generally subjected to direct shear as well as twisting, and we know that inside portion of the spring wire is subjected to more shear stress, so it is also subjected to direct shear, whose magnitude is 4f divided by pi d square. Okay, if I consider that this wire is subjected to direct shear as well as twisting, we can also say that this is subjected to twisting, right? So twisting shear stress is how much? It is 16t by pi d cube. Okay, we know that t is nothing but ef into d by 2, where so 2 and 16 cancels out. So depending on the kind of options that are given, we can either choose this as the answer or this as the answer. So as the options are not mentioned by the student, so let's assume that, so it is given in terms of 4f by pi d square and pi d cube. So considering the options like this, so this will be the equation for tau max considering the effects of direct shear. Moving to the next one, it is from the concept of welding. So he said that there is a plate which is subjected to a load P. Okay, and here this plate is welded to the surface like this, and we have weld here. Let's assume that this is the weld. From the data given by the students, it is mentioned that the length of this weld is mentioned as L. Considering the length of weld to be, this is the length of weld. He also said that tau allowable. So this is the allowable shear stress in the weld material. This is the allowable shear stress in the weld material. Okay, considering the size of weld to be H is considered to be the size of weld. Okay, so can you please say me, so what is the load capacity of this weld? So we know that the load which is applied on this member should always be kept below its strength, shear strength of the weld. What is the equation for shear strength of fillet weld? It is nothing but SYS, which we have seen, SYS into 0.707 times H into L. We know that 0.707 is nothing but 1 by root 2. So considering this to be 1 by root 2, so depending on the kind of options that are given, okay, so in place of SYS, we can replace that by tau allowable. Okay, so into 1 by or H by root 2 into L. So the value of load, the load should always be kept below this value. I guess you have solved all these three equations. Okay, hope you are going to get good marks in GATE examination. I wish you all the best. Now, Sharma sir will be handling the questions from heat transfer.
Hello, good evening. For heat transfer, I'm Dr. G.S. Sharma. As of now, the count is, 3 2 marks questions and 1 mark question, but I could get only 2 questions out of the memory base. It is definitely tough for students to, memorize and give us back the data, but authentically, whatever data I have got it. One question is on fin. It said that there's a square fin of side equal to S. There's a square fin. And then it is said that this particular square fin is replaced by a circular fin. By a circular fin wherein its diameter equal to the side of the square. And then it was asked, what is the ratio of heat transfer for square fin to ratio of the heat transfer or ratio of heat transfer of square fin to that of a circular. This is what the question is. Now if you look at it, nowhere the conditions of whether it is infinitely long fin, short fin, or short fin with convective convective conditions or prescribed boundary temperatures, they were not specified. So you assume that it should be an infinitely long fin because nowhere in the question they have discussed about the length. And if you look at heat transfer in an infinitely, heat dissipated by a fin for infinitely long is given by Kam into theta b, or in the class we have discussed HPKA into theta b, where H is heat transfer coefficient, K is thermal conductivity. Nowhere they have discussed that material is changed. So K is same, thermal environment is same. So I will write the ratio of heat transfer in a square fin to that of your circular fin is nothing but under root of perimeter of square fin into area of square fin divided by under root of perimeter of circular fin to area of the circular cross section of that particular fin. This should be. Now let's write it in numericals. If you are writing it under root of perimeter of a square cross section fin is 4s, area is s square divided by under root of, for circular cross section perimeter is pi into d and area is, sorry, 1 minute, I will, because d is nothing but s. This is s. He has given because diameter is equal to the side of the square. So pi into s into area is pi by 4 s square. So under root of s cube and under root of s cube get cancelled. Numerator are 2 into under root of s cube divided by pi into pi, pi square by 4. When it come out, it becomes pi by 2 into root s cube. These two get cancelled. This 2 goes to the numerator. It is 4 by pi, which is 1.27. 1.27. So this is what the answer is. I don't know how that particular question interpretations, which particular options they might have given, but it all depends on this particular frame. This is the first question that I could give you till now. And if you look at the second question is on transient. He has given a sphere of diameter equal to 10 mm. This is a sphere. And it is said that initially Ti is at 400 degrees centigrade and it is kept in an ambient of temperature equal to 20 degrees centigrade, wherein he is asking you that what is the time that is required for this particular sphere to reach a temperature of 50 degrees centigrade. A sphere of 10 mm diameter kept in an environment of 20 degrees centigrade, having heat transfer coefficient H equal to 500 watt per meter square Kelvin. H value is also given and the properties. Then he's asking you what is the time required for it. So if you write it, T minus T infinity, transient, T naught minus T infinity, assuming that Biot number is less than 0.1, lumped heat capacity analysis is applied, e to the power of minus H by rho into Cp into As by V is nothing but volume divided by surface area is equal to R by 3. So it comes out to be 3 by R into tau. Given H, rho, Cp and radius, you will calculate tau, time, when this value is 50 minus 20 divided by 400 minus 20 equal to e to the power of minus 3h by rho into Cp into this radius is 5 mm, 5 into 10 power minus 3 into tau. Given these properties, take antilogs, we'll get the answer. These are the two particular questions. And even I have got information telling that the question was asked on emissivities and heat exchangers. They're still in the process of formation, but all for same. They're all taught in the class. All the best, students of ACE Academy. And Malkondeya sir, my good friend, will come down and take up the thermal engineering for you, right? Yeah, thank you.
Hi students. Now let us discuss the solutions for thermal questions. These are memory based questions. I received 5 questions. Among the 5 questions, 2 are from non-flow process. 1 is from properties of the pure materials. 1 question from Rankine cycle. And the other question is for Exergy or available energy. Okay. Look at the first question, what I received. For the isothermal expansion of an ideal gas in a piston cylinder system, the net heat supplied during the process is equal to net work transfer. Which of the following statements is correct for the given process? Different options are available. Option A, the process is possible. Option B, the process is possible, however, it violates the second law of thermodynamics. Option C, the process is not possible as it violates the second law of thermodynamics. Option D, the process is not possible as it is violating the first law of thermodynamics. Since it is given for isothermal process with ideal gas, you know, for ideal gas, internal energy U is the function of only temperature. Since internal energy is the function of temperature, the U1 equal to mCv T1 and U2 is equal to mCv T2, because internal energy general formula U equal to m into Cv into T. Then what is the change in internal energy? U2 minus U1, it is equal to mCv into T2 minus T1. But given problem is for isothermal process where T1 and T2 both are identical. Since T1 and T2 are identical, this difference is becoming 0, the du equal to 0. Then for any non-flow process, energy balance equation is Q equal to W plus du. This is the non-flow energy equation. Here du equal to 0. Since du equal to 0, heat transfer is equal to work transfer. For isothermal process, if material is ideal gas, heat transfer and work transfer both are equal for isothermal process. Now, the first option is the process is possible, definitely, because heat transfer is given. Heat supplied during the process equal to work transfer, right? That is absolutely correct. Option A correct. Look at the B. The process is possible, however, it is violating the second law of thermodynamics. No. Second law of thermodynamics is connected to cyclic process. Second law of thermodynamics is completely explained by the 2 statements, Clausius statement and Kelvin-Planck statement. Both are talking about the cyclic process, but the given problem is for a process only, not for a cyclic process. Whether it is Clausius statement for the refrigeration systems or Kelvin-Planck statement for heat engines, both are talking about the cyclic process only, but the given problem for process, no way this question connected to second law, therefore option A can be taken. Okay. Next, look at the next one, what I received like this. For an ideal gas, starting from state point 1, 2 different process takes place. The corresponding final states in these 2 processes are 2 and 3. Initial state of the gas is 1. To reach the final state, he approached 2 processes, right? 2 and 3. Finally, that means the process may be like this. The process may be like this. This is the PV diagram, pressure versus volume diagram. Pressure versus volume diagram. This is the initial state. 1, 2 to 1 process like this. 1, 2 to 1 process like this. 1, 2, 3 another process like this. 1, 2, 3 another process like this. Then what is happening at state 2 and state 3? Lying on the same isothermal. That means 2 and 3 are lying on the isothermal. Its meaning is temperature at state 2 equal to temperature at state 3. Right? Temperature at state 2 and temperature at state 3 both are identical, because the state 2 and 3 are lying on the same isothermal. Then if P and H represent the pressure and enthalpy respectively, then which of the following options is correct. Since it is given for ideal gas, for any ideal gas according to Boyle's law, as long as the temperatures are remaining constant, right, product of pressure and volume at state 2, product of pressure and volume remains constant. Then product of pressure and volume at state 2 equal to product of pressure and volume at state 3, P3 V3, right? Now as you know the at state 2 and state 3 interlange U2 equal to U3, because for ideal gas interlange is the function of only temperature. But what is the enthalpy? Enthalpy H equal to U plus PV. Then I can write H2 equal to otherwise U. From that I can write that, एक minute, should be very careful, right? U equal to enthalpy minus PV. Then U2 equal to H2 minus P2 V2, and U3 equal to H3 minus P3 V3. Since at state 2 and state 3 interlanges are remaining same, in the place of U2 write the H2 minus P2 V2 is equal to H3 minus P3 V3. But according to Boyle's law, as long as the temperatures are equal at state 2 and state 3 for any ideal gas, P2 V2 equal to P3 V3, therefore these two fellows are getting cancelled. Finally it is equal to H2 equal to H3. Enthalpy remains same. Otherwise, as long as the temperatures are remaining same, enthalpy also remaining same for ideal gas, because for ideal gas enthalpy is depending on only temperature, like how the interlange is depending on only temperature. Anyhow, H2 equal to H3 is absolute correct answer. Look at the option D. Option D is absolutely correct. Okay. Next, look at this one. It is asking like this: a rigid closed vertical cylindrical vessel of 15 centimeters diameter contains 5 kg of water at 80 degrees centigrade and 10% quality. Dryness fraction is 10%, right? Okay, X equal to dryness fraction X equal to 0.1. The water is heated till its temperature. Reaches to 130 degrees centigrade. Considering only a horizontal separated interface between the liquid and vapor, the drop in the liquid level after the heating process dash in centimeters. The properties of the water at various saturation temperatures are to be, the table is not given. Anyhow, it is asking a rigid closed vertical cylinder vessel of 15 cm diameter contains 5 kg of water at 80 degrees centigrade, 10% quality. The water is heated till its temperature. Rigid closed vertical cylindrical vessel, only diameter is given. You need to decide the specific volume. For finding the specific volume for cylindrical, specific volume equal to what? Specific volume is equal to volume by mass. Specific volume equal to volume by mass. Otherwise, no initial quality is given. You can find it, no problem. V wet equal to, initial quality is wet, na? Initial quality is wet. V wet equal to what? Vf plus XVFG. That is the specific volume of the wet vapor corresponding to 80 degrees centigrade. Here Vf value I have taken, this table is not drawn here. From the steam tables I have taken Vf value 0.001029 meter cube per kg plus X value given 0.1. Dryness fraction 10% quality means dryness fraction is 0.1. Then VFG value I took from the steam tables 3.404271. So that might be the values given in the table. With this the value I got is 0.3414 meter cube per kg. This is the specific volume of the wet vapor. That is the specific volume of the wet vapor. Then what is the critical volume? Critical volume equal to 0.00315 meter cube per kg. Now compare the specific volume of the wet vapor with the critical volume. The specific volume of the wet vapor is more than critical volume. Then the TS diagram or TV diagram, temperature versus volume diagram, temperature versus volume diagram, specific volume diagram. The saturation dome is appearing like this. This is the saturated liquid curve and this is the saturated vapor curve. The apex point is representing the critical volume, where critical point where the volume is VC. This VC is less than the wet vapor volume, specific volume. Corresponding to 80 degrees centigrade, right? The initial volume is V wet. Final temperature of the wet steam is, look at the final temperature, 130 degrees centigrade. Final temperature 130 degrees centigrade. This is the final temperature 130 degrees centigrade. Since the initial specific volume of the wet vapor is more than critical volume, this may be the initial state of the wet vapor. This is the V wet value, initial specific volume of the wet vapor. Now here specific volume of the wet vapor is more than critical volume. When you heat that wet steam which is present in the rigid vessel at constant volume, the heating process can be represented like this. 1, 2, 2 is the heating process. Now look at the state 2. The state 2 is very close to saturated vapor curve. Since the state 2 is very close to saturation vapor curve, vapor content increases. When the vapor content increases, definitely liquid content decreases. So what it is asking, right? The drop in the liquid level after the heating process is in centimeters, it is asking, right? So actually if it is asking liquid level whether it is increasing or decreasing, definitely liquid level decreases. Liquid level decreases, that can be decided. It is asking liquid level after the heating process in centimeters, right? That I need to check it. Right, generally the question will be asking whether the liquid level is increasing or decreasing. So it is not correct according to the question what I got from my students. Right, it may be right wrongly printed. Anyhow, the drop in the liquid level, it may not be correct. Whether it may be asking what about the level of the liquid. Generally, if it is asking level of the liquid, if it is asking just level of the liquid, definitely level of the liquid decreases. Right, because the state 2 is very close to saturated vapor curve, right? So that is the answer for this particular question. Anyhow, I thought that this point, right, may not be given. It may be, right, what one of my students told that, what about the liquid level, whether it is increasing or decreasing or remaining constant? Definitely liquid level decreases. So that is the answer. Anyhow, since the state 2 is very close to saturated vapor curve, definitely the vapor content increases, proportionately liquid level decreases. That is the answer, right? Similarly, look at this next one. For an ideal regenerative Rankine cycle, as shown in the figure below, which one of the following options is the correct representation of TS diagram? It is given for ideal Rankine cycle. For ideal Rankine cycle, this is the representation of the right TS diagram. We have clearly discussed in the classroom. It is the temperature versus entropy diagram. The slope of this line and the slope of the 2 to 3 must be, right, equal. This means 2 to 3 and this 4 to K parallel, because the temperature drop of the steam is equal to temperature gain of the water with the same change in entropy. So this is the TS diagram for ideal Rankine cycle. Ideal Rankine cycle is for the concept of Carnotization of the Rankine cycle. Anyhow, B is correct. Look at the last one. It is asking like this. A liquid comes out of the reactor of a chemical plant at 250 degrees centigrade temperature with a flow rate of 100 liters per minute. Here volume flow rate is given. Volume flow rate equal to 100 liters per minute. it is equal to 0.1 meter cube per minute. Meter cube per minute. It is equal to 0.1 dividing by 60 meter cube per second. That is the volume flow rate. The ambient temperature is given 25 degrees centigrade. Initial temperature, that is equal to ambient temperature, atmospheric temperature 25 degrees centigrade. That is equal to 298 Kelvin. Density and specific heat of the liquid remains constant at the density of the water is given. Density of the water is 1000 kg per meter cube, and specific heat of the water, that is standard value, specific heat of the water is given 4.18 kilojoules per kilogram Kelvin. Respectively, for the given range of temperature, the rate of exergy associated with the hot liquid stream at the exit of the plant. What is the initial temperature? 250 degrees. Initial means temperature of the water at the exit of the reactor. So temperature of the water at the exit of the reactor, that I am marking as T2, that is equal to 250 degrees centigrade. This 250 degrees centigrade is equal to 523 Kelvin plus 273. Since initial temperature of water is not given, I am assuming atmospheric temperature and initial temperature of the water both are equal. Anyhow, water is available at high temperature. Then what is the energy content in the water? That is the heat energy. Heat energy equal to mass of the water into Cp of the water into final temperature of water minus initial temperature of water. Mass of the water not given, but you know density rho equal to mass by volume. From this mass flow rate equal to, or mass equal density multiplied by volume, or mass flow rate equal to density multiplied by volume flow rate. Volume flow rate. It is equal to density multiplied by volume flow rate into Cp of the water into T2 minus T1. Here density of the water is given 1000, that is standard value. Volume flow rate of the water 0.1 dividing by 60, 0.1 dividing by 60 into 4.18, that is the specific heat of the water, into T2. Since that is the difference, we can write either in Kelvin or degree centigrade, 250 minus 25. 250 minus 25. So you simplify this value for getting the heat transfer rate. My calculator has shown 1567.5 kilojoules per second. Kilojoules per second. Right? But what is the available energy of the Q? Available energy of Q equal to Q minus T naught ds. Available energy of the Q is Q minus T naught ds. ds for water. ds for water. Water is a liquid. Right? Liquid is having only one formula for finding the change in entropy. M into Cp into Ln, final temperature of water, dividing by initial temperature of water. Here mass of the water is 1000 into 0.1 dividing by 60 multiplied by 4.18 natural log ln T2. T2 it should be in Kelvin because that is the temperature ratio. 523 dividing by 298. 523 dividing by 298. You simplify this value for getting the change in entropy. My calculator has shown 3.918. That is the ds value. Then available energy of the Q is Q minus T naught ds. 1567.5 minus 298 multiplied by 3.918. You simplify this value for getting approximately 400 kilowatts. Approximately, right? So that is the answer. Alright, here kilowatts I got my calculator has shown 399.73, approximately 400 kilowatts. So that is the answer. Very easy question, right? I hope all of you attempted perfectly because these are all the questions we discussed in the almost similar questions we discussed in the classroom, right? Have understood? Right. Thank you very much.
Hello guys, now we see the questions from SYM, Theory of Machines and Engineering Mechanics guys. The questions are quite easy, except one question from Theory of Machines, remaining all are quite easy guys. Now we'll see the first question. What is a SF and BM diagram for this guys? Now if you observe carefully, see, if I can divide this one into three segments, A, B, C. A to B, what happens guys? No shear force exists, no load exists guys. So here to here, my shear force diagram become, here to here, no shear force. Again, if you're looking from right hand side, load downward means shear force should be upward. Again, here to here, completely constant. This is a typical shear force diagram guys. How is the bending moment diagram? As I told you already guys, here, whenever point couple exists, there must be a vertical step should exist guys. How is the vertical step? Upward, downward sir? It is a counterclockwise couple. Water storing sir. Water storing means positive. Positive means should be vertical step upward direction. Here vertical step upward direction guys. Until this moment is constant sir. Same thing will be continued here guys. PL by 2. Now the problem is, what is the moment at this edge? Moment at this edge. How can you find out sir? Assume this is a point A. Moment at C equal to how much guys? Moment at C equal to the constant moment PL by 2 and downward means negative guys, minus P into distance how much again? L by 2. PL by 2 is coming as 0 sir. So it is going to be 0. This is a typical SFD. This is a typical BMD guys. And even if the SFD is given like this also, it is correct sir. It is correct because sign convention will be different for different guys. If they given this one or this one, both will be correct only. Exactly what they have given, we don't know sir. Okay, this is about the word question. Next question guys, briefly I'll explain you. What he has given is allowable normal strain he has given guys. The allowable normal strain is given as 0.00034. Then what is the pressure, allowable pressure inside of a thin cylinder guys? How can we find out sir? So allowable normal strain, which strain is more actually? You know hoof stress is more. As the hoof stress is more, hoof strain will be more guys. But what is the hoof strain formula? E1 equal to, I can write down 1 by E into sigma H minus V times of sigma L must be equal to, this is the value you have to keep it guys. That's it. One single formula you can able to get it. Here 1 by E into, what is sigma H guys? PD by 2T minus V into PD by 4T guys into whatever the allowable strain he has given. Here substitute the D value, T value and everything guys, and here unknown is P, you can able to get from this formula guys. Whatever you are getting from this equation, that is more than sufficient. That is a correct one guys. Now coming to this question, again straightforward question guys. He has given that there is a load acting at this location. It is an unsymmetric beam sir, because this is the 2, this is the 3 he has given. Then point C on the neutral axis and tau at point C is given as 3 megapascal guys. Then what is the value of P guys? The shear stress at this location guys. So what is the shear stress formula sir? Anyone remember? Shear stress tau max equal to, it is a rectangular cross section guys, because if you see the dimensions it is visible for you. The rectangular cross section, shear stress equal, tau max equal how much? 3 by 2 times of tau average. This value is given as how much guys? 3 he has given, that's it. This is the 3. Now the problem here is tau average equal to how much guys? Tau average means V by BH. I know B value, I know H value guys. And unknown is what exactly? V. How can you find out the V? Shear force at this location equal to, it is easy to calculate from the left side or right side guys. Left side is easy, only one support reaction. How can you find out support reaction guys? It is the, is unsymmetric guys. This is the A, this is the B. This should be how much guys? PB by L. PB by L means how much? P into 3 by L, how much guys? 5. So 3P by 5 is the my support reaction here. So shear for this location equal how much guys? 3P by 5 itself. So 3 by 2 into again 3P by 5 by area. Area how much guys? 20 into 45. Take care of the units guys, that equal to 3 megapascal. Approximately you are going to get, let me check, 3000 newtons guys. 3000 newtons you are going to get P equal to, or 3 kilonewtons guys. So please, this is the procedure, sir. If this is the question, exact question, this should be the procedure, guys. Now, vertical reaction at C. Again, straightforward question, 2 marks question, guys. Vertical reaction at C. This is the C point, guys. So this is the C point. And here, observe carefully, sir. I'm sorry, this 10 is exactly at the center, guys, center of this side itself. This is the A, this is the B, as is the B dash is the internal hinge, guys. Whenever internal hinge is given, what I can able to do, guys, please go through it. Here, this is the 10. Here, 2 reactions will be coming, guys, 5, 5. Same 5 will be acting on this right side of the beam itself. This is the same. Why I have taken 5, 5, guys? Because it is symmetric, sir. 5, 5. This is the place your B will be present, guys. And here, 25 is acting. 25 kilonewtons. This is the RC. Is asking RC equal to how much? It become typical finding the support reactions itself. This is the 0.2. This is the 0.2. This is the 0.6, guys. Now what you can do, take moment about B. If you take moment about B equal to 0, about B, clockwise must be equal to anti-clockwise, guys. If you take about B, sir, RC will give you clockwise. How much? RC into 0.8 will give you clockwise. Next, 5 also gives you clockwise. 5 into 0.2. Next, tell me, guys, 25 will give you anti-clockwise, guys. 25 into 0.2. Sorry, sir. This is the anti-clockwise. This is the clockwise, guys. So anti-clockwise must be equal to clockwise. Just calculate. You are going to get RC equal to 5 kilonewtons, guys. That's it. Again, straightforward question. Next, this is a question from engineering mechanics, guys. The question was a block of 50 kg. Some figure was missing, sir. Let me draw the figure he has given. Again, straight away question, sir. This is the block he has given. This is the block. One pulleys are there, guys. This is the one. This is the question, guys. The question here is the block having a weight of how much? 50 kg, guys. This block having a weight of 50 kg, then how much mass is required to move the block upward direction? Here he has given that coefficient of friction exists only between these two. There is a 0.3 he has given, sir. Now, how can we do it, guys? Let me draw the free body diagram of the 50 kg. See, this is the 50 kg free body diagram. Weight how much? 50 times of G. Next, here, normal reaction exists, guys. Normal reaction exists. Next, this is a frictionless pulleys, guys. So this is the M. So this should be how much, guys? Mg will be the weight will be acting. Mg here also Mg, sir. So 2 Mg will be acting in this direction. 2 Mg will be acting here, guys. How is the friction force? The block is moving upward, means friction will try to act in the downward direction, guys. This is the mu times of N. This angle is how much? Angle of inclination is given as 30 degrees, guys. Now you can solve it. Just left equal to right, upward equal downward. You can able to solve it, guys. Simple. This side upward equal to this side downward. So N equal to how much, guys? 50G cos 30. Now tell me, sir. This side downward equal to this side upward. So this side downward how much, guys? 50G sin 30 plus mu n, that equal to 2 times of mg. Unknown is what exactly, sir? M itself. If you can just calculate, going to approximately 19 kg you are going to get. 19 kg you are going to get. Whether right or wrong, we don't know, guys. As for the data, we are getting 19 kg, guys. Okay. Now we'll see some of the questions from theory of machines, sir. So only few questions like received, almost 3 to 4 questions we received, guys. We will discuss those questions from theory of machines. See, guys. One question given on the gyroscope, guys. There's an aeroplane. 1 second. Yes, there is an aeroplane, is, guys. Aeroplane rotor is having a inertia I given 1 kg meter square, and it is having the rotor having a speed of 500 RPM, guys, and it is taking a turn. How it is taking a turn, guys? With radius. This is the radius of 2 kilometers, radius of 2 kilometers, and the aeroplane is moving with a velocity of how much? 1200 kmph, guys. Velocity equal to 1200 kmph. Then the question is asking what is the gyroscopic torque equal to how much? Direct formula, sir. T equal to I omega S omega P. I how much, guys? 1. Omega S, guys. What the omega S, guys? 500 RPM is given, but I want in terms of radians per second. It should be how much? 2 pi into 500 by 60 into omega p, guys. I want omega p. What is mean by omega p, guys? Omega pressure, how can you find out? As I know V equal to R omega p itself. So omega p equal to how much, guys? V by R. You should be take care of the units. But V is given 1200 kmph, guys, which means that 1200 into 5 by 18 meters per second by radius equal how much, guys? 2 kilometers means 2000 meters, guys. So how much is coming, sir, from this one? Approximately 8.7 Newton meter you're going to get, guys, about this one. Next, one more question they're given, guys. The question is on, there is a ladder. This is a ladder. This is the point A. This point, this side is having a motion of 6 meters per second. Then exactly center, what is the velocity of G he's asking, guys. From velocity analysis you can able to do it, guys, from the mechanisms. How can this angle is given as 45 degrees. 45 degrees. First, where is I center for this? If I know I center, I can able to just draw a perpendicular lines. Draw a perpendicular lines. This is the I center, guys. This is the I center. Because angle is 45 degrees, guys. This will be exactly perpendicular. This is how exactly VG will be coming, sir. So I can able to write VG equal to how much, guys? IG into omega. S or no? IG into omega. Now, how can you get IG, guys? If I know IA, this angle equal to 45 degrees, guys. IA sin or cos? This side should be IA sin. IA sin 45 degrees into omega is the VG I am going to get, guys. Now observe carefully. Then VA is given as how much, guys? VA equal to IA into omega, sir. IA into omega. This is equal to given as 6, guys. Now I can able to get VG by 6. Just VG by VA means 6 equal to IA into sine 45 means how much, guys? 1 by root 2. 1 by root 2 into omega by again IA into omega, guys. IA into omega. These two getting cancelled. So VG equal to how much? 6 by root 2, sir. So how much is this answer, guys? 4.24. 4 meters per second, guys. I hope you understood, sir. Like if you need further questions, guys. Anyway, like the moment we get the full paper, guys, we send the clear video solutions of all the entire paper of my particular subjects, guys. I hope you have written well about this design related subjects, guys. Wish you all the best. Thank you so much, guys.
Now I'll discuss about the questions given in mathematics paper. So whatever, so far we have received the 6 questions from the mathematics part from the students. So let us discuss the solutions of all these. Now this is the first question. This question is from the differential equation topic. That too in particular it is question is from partial differential equation. So very simple question. Directly we can answer this. It doesn't take more time. The order and degree of the following differential equation are m and n respectively. Order is the m and degree is given by n. Okay, m is the order of the differential equation, n is the degree of the differential equation. And we are asked to find the difference of them. According to definition of order of the differential equation, order of the differential equation is the order of the highest order derivative. These two are third order, which are the highest order derivatives. So order of the derivatives is 3. That is m equal to 3. Next, to write the degree, we consider the power of the highest order derivatives. Power of the highest order. The power of this is 1. The power of this is 1. Whenever more than one highest order derivative is present, like this, we observe their powers. Out of these two, if any one is bigger number, that is the degree on it. That is, highest power of the highest order derivatives is the degree of the differential equation. So degree is here 1. And the difference is m minus n. m minus n equal to 3 minus 1 equal to 2. It is the answer. Just we are asked to find the difference of these two on. So B is the answer. This is about the first question. Now let us go to the next problem. This is a question from the vector calculus part. That too, it belongs to the particular vector differentiation part. Phi is a scalar function. Phi is a scalar function. If you take this equal to constant, this is the equation of the surface of the some object in 3D space or 2D space on. And here we are asked to find the del phi. Del phi is the gradient of a scalar function at any position on the scalar position or scalar field. Now, according to definition of gradient of a scalar function is the normal to the surface. When you are finding the gradient or del phi means that gives the normal to surface. Normal means perpendicular to the surface. So del phi is a vector. This is the vector perpendicular to this surface. That is why this is the correct answer. So this is the correct answer. Del phi is always perpendicular to the surface of the given this. Now this is about the second problem. Next we go to next problem, problem number 3. It is a direct question like previous one. Newton-Raphson method for solving algebraic equation is based on power series, Fourier series, Lorentz series or Taylor series. Already we know that the Newton-Raphson iterative formula will be obtained from the Taylor series by linear approximation. From the Taylor series approximation, by writing the linear approximation, we can add the Newton-Raphson formula. That is why the answer is last one, D. The NR method for solving the algebraic equation is based on only Taylor series. So last option is correct. Now let us go to the next problem. It is a question from the calculus. In particular, this belongs to the multiple integral, and also here it is given that the double integral problem. Very simple function is given inside the integral, but limits of the integral are not given. Instead of giving the limits of the integral, we are given the region of integration. So with the information of the given region of integration, we try to draw the diagram and we try to find the limits. After finding the limits, we can evaluate the integral. Now the region A, we always evaluate double integral over the region, and here the region notation is A. It is given by the parabola curve x square equal to 4y and the ordinate x equal to 2 and x-axis. With these three, we try to draw the diagram and then we find the limits of the integral. X-axis, y-axis, it is just like x square equal to 4ay form or y equal to x square form. Now this is the parabola x square equal to 4y or y equal to x square by 4. Next, x-axis. it is x-axis. Equation of x-axis is y equal to 0. And equation of y-axis is x equal to 0. Next, x equal to 2. This is x equal to 0, x equal to 1, x equal to 2. This is x equal to 2. So finally, the region A will be bounded by the curve x square equal to 4y, x equal to 2 and x-axis, that is y equal to 0. So over this region, we need to evaluate the integral. Now from this region, we can find the limits by drawing a line perpendicular to or parallel to y-axis or parallel to x-axis, or by taking the vertical strip or by taking the horizontal strip, we can find the limits anyway. We can. Now let us consider the vertical strip or vertical line that is parallel to y-axis or perpendicular to this. Now I am drawing the line parallel to y-axis in increasing direction of y-axis. This line enters the region through this curve, so it is entering curve. This entering curve will give the lower limit of y, and the same line passes through region, leaves the region through this. So this leaving curve will give the upper limit of this variable y, and that is given by this equation. So we write the y in terms of other, y equal to x square by 4. And this region, this line is entering the region through this curve. So this entering curve will give the lower limit of y, and this is given by equation of this x-axis y equal to 0. So y will vary from this curve to this curve, that is y equal to 0 to y equal to x square by 4. And to cover this total region, we can draw the lines from 0 to 2. X will vary from 0 to 2, y will vary from 0 to x square by 4. Now these are the limits. X limits are 0 to 2, y equal to 0 to x square by 4. With these limits, we evaluate the integral. Now I equal to. According to these limits, y limits are variable limits, x limits are constant limits. Whenever the variable limits are given, there will be order of integration. Always we start with the variable limits y and then stop the integration with the constant limits. So I equal to, we write the order of integration, integral x equal to 0 to 2. Inside this integral y equal to 0 to x square by 4 y dy and then dx, which implies I equal to integral x equal to 0 to 2. Integral of y is y square by 2 from 0 to x square by 4 dx. Now substitute upper limit and lower limit. Anyhow, lower limit is 0, just we substitute this, and 1 by 2 is constant, we write this outside. I equal to 1 by 2 integral 0 to 2. These are the limits for x, and in place of y, write the x square by 4 square. So x power 4 by 16 dx. Integration with respect to y is completed. Now integrate with respect to x, which implies I equal to 1 by 32. Next, integral of x power 4 is x power 5 by 5 from 0 to 2. Now at the end of simplification, this will be I equal to 1 by 5. So this is about the problem from the multiple integral topic. Now let us go to the next problem. This is a question from the differential equation. In particular, it belongs to the partial differential equation. Differential equation is given along with the particular condition. Whenever the particular condition is given, means we can add the solution, and that solution is a particular solution. Particular solution is given already in the option. Whenever the particular solution is required, options will be given like this. If possible, we can choose answer by verification, but here this is satisfied with more than one option. So in this problem, we cannot choose the answer by verification method, so we should do the problem by method. Now to find the solution of this homogeneous linear differential equation, we have the method of separation of variables. According to method of separation of variables, after finding the solution, the general solution will be in the form of y of x comma t equal to c1 into c2 constant. Next, e power kx plus k minus 1 by 3 into t. The solution of the differential equation is same as finding the dependent variable y in terms of independent variables x and t satisfying this equation. According to method of separation of variables, the solution of this equation is given by this. This is the general solution. Already we are given condition, so we apply the condition. The condition is y of x comma 0 equal to 10 into e power minus 2x. So when you compare this with this, c1, c2 is 10 and comparing with this, that is if you apply this condition means substitute t equal to 0. When you substitute t equal to 0, this part will become 0. Just we get the c1 c2 e power kx. Comparing this with this, k equal to minus 2 and k equal to minus 2. Now we know the c1 c2 value, k value, and substituting these two here, we get the one of the particular solution. That is this option. It is the correct answer. Now let us go to the next problem. It is a question from the numerical methods. The exact solution of this integral is represented as n. So n is given as exact solution of this differential. That is, exact solution means exact value of the integral. So we calculate the exact value. Integral x equal to 0 to 4 1 by 1 plus x dx. Now integral of 1 by 1 plus, this function is integrable, so we can do the integration by general method. Integral of 1 by 1 plus x is log of 1 plus x from 0 to 4. Substituting upper limit, lower limit, we get the, for x equal to 4, log 5 and log 0, here log of 1 plus 0, that is log 1, 0. So log 5, it is the exact value. Or by using the calculator, if we write the in decimal form, this will be 1.6094. This is the exact value. This is the exact value, n. Next, if m represents numerically evaluated value of the above integral using trapezoidal rule, considering 4 equal sub-intervals. So number of intervals is 4. Now according to this trapezoidal rule, the formula is given by, and this is denoted by or represented by like this m. So m equal to integral a to b approximated polynomial p of x dx, and this is given by h by 2. According to given data, we write the formula, but for the data we require the h. H is given by the b minus a by number of intervals, that is already given 4. So b is a to b, 4 minus 0. So this will be 1. H is 1. Now we form the table. X values, y values, which is given by the function 1 by 1 plus x. Now start with the initial value a or x naught. X naught is here 0, and adding h, we get the next values. The next is x1. X1 is here 1. X2 is 2. Next 3. Start with the initial value, add with h, so that we get the last one 4. This is x naught, this is x1, this is x2, this is x3, this is x4, and the corresponding values are y naught, y1, y2, y3, y4. Now using this function, in place of x, substitute the 0, 1, 2, 3 and so on, we can add the function values. So totally how many values here? 1, 2, 3, 4, 5. According to this given data points, the formula will be sum of the first and last y0 plus y4 plus 2 times of sum of the remaining y1 plus y2 plus y3. Now when you substitute x equal to 0, this becomes 1 by 1. For x equal to 1, this becomes 1 by 2. For x equal to 2, this becomes 1 by 3, 1 by 4, 1 by 5. Now after substituting all these y values in this, and if we simplify this, we get the m as 1.6833. This is approximated value given by the trapezoidal rule, and this is the exact value given by the exact method. Now we require the difference, m minus n. Therefore m minus n equal to this minus this will give the this option C, 0.074. That's it. This is the answer. So these are the questions from the mathematics part. With this, all the mathematics questions are completed because we have received only just 6 questions.
Right. Right. Now here I'm going to discuss about some questions from the production. Here is a question from the production. A 2D surface profile is obtained over a sampling length by using a contact type stylus profilometer as shown in the figure. A line AA parallel to the general lay of the trace is considered. The true heights from AA to the peaks and valley in the trace are also shown in the figure. The 10-point average in mm. So it's a very simple question. Here you should consider 10-point average. See, remember this 10-point average here I'm taking the peak values, 5 values I'm taking, and this values, five values I'm taking. Let us consider this value, this value, this value, this value, like that. Okay, na? And one more value I can take it as 62, like that. Some 5 peak values I'm taking and 5 values I'm taking, like this value, this value, this value. Okay, nearest values, like that. If I take the values, so 5 peak values and 5 values, let us consider 6.7 plus 8.3 plus 6.3 plus 6.9 plus 6.2 minus, okay, and 2.82, okay, plus 4.2 plus 2.9 plus 4.26 plus 4.3 divided by 5. If I consider, if you solve this question, you will get nearly 3.006 micrometer you will get. So here C is the correct option. So it's a very simple basic question. Now here is a question from the casting defects. Okay, they are given 3 defects: dross, scab and scar. Now dross is actually related to impurities. So if there is impurities present in the casted component, then the defect we call it as a impurities. Now scar, you can say there is a air or gas trapped in the casted component, and scab is nothing but, okay, a scab is nothing but a rough thin layer of metal above the sand casting. Suppose if I consider above the sand, because of the loose sand, a rough thin layer is going to be occupied on the surface of the casted component due to the improper ramping of the sand. So that this is, you can take here, dross is related to impurities, so P is related to 2, okay, and R is related to, R is a scab related to 3, R is related to 3, and S is related to shallow blow found on a flat casting, so S is equal to 1. It's a very simple question. Now here is a question from the jigs and fixers. Okay, a workpiece is to be firmly held in fixture. It is to be machined by using a plane slab milling cutter as shown in the figure below. Which one of the following option is the most suitable value of height h of the fixture? See, always remember here the workpiece height is 205 given. So fixture height must be less than 205. But if it is very small, suppose if the fixture value, if it is very, very small, then this will become like a cantilever beam. Here are the options, I think not given. Here I'll give you options. I think so from the student data, options are like 70, B 145, C 210, okay, D 200, like that it is given options. Now if you see here, if the fixture height is very, very small compared to the workpiece, then that will become a cantilever beam, so that won't be that fixture. So this is going to be eliminated first. It won't be 70. Then fixture height should not be very nearer. Suppose if this workpiece height is 205, then fixture height is 210 or 200. It's very difficult to do the machining operation, right? So it is also not economical. So these two are also eliminated. they are uneconomical. So the most appropriate answer for this question is 145. B is the most appropriate answer. Right. Here is a question from the additive manufacturing. Which one of the following options is not an error associated with a stereolithography STL file in additive manufacturing? See, which one of the following is not an error in stereolithography? See, missing facet is an error. Okay, degenerate facet is an error. Non-manifold topography condition is also an error. So stair cast facet is not an error. So this is the correct option for this question. B is the correct option for this question. Now, this is a question from the orthogonal cutting, orthogonal turning. Now see here, during orthogonal turning by using a single point cutting tool, feed is given 0.24 mm per revolution. Okay, and the uncut chip thickness is 0.23. The shear angle, tangential force component and radial force component are, now see here, shear angle is 20 degrees. Tangential force component, let us consider tangential force component, I am taking Ft, that is tangential force component 800 newtons, and then radial force component, it is given 150 Newton. Right, what they are asking, the value of shear force. Here the value of shear force, if you want, the shear force formula you are familiar, that is Fc cos phi, okay, minus Ft sin pi. Okay, here Fc is how much? See here, Fc is how much? Fc cot phi, tangential force and shear force. Let us consider here it is not Fc, it is I think Ft and Fc. So 800 cos 20 degrees minus 150 sin 20 degrees, maybe data mismatching. Here by solving this question you will get nearly 700 Newton is the correct option. Okay, right, this is the correct option from the orthogonal cutting. And this is another question from the drilling operation. Here a drill bit during its lifetime can produce 150 through holes in a plate at a drill speed of 200 rpm. See the number of, remember number of holes, let us consider here. Suppose let us consider the number of holes 150, then after that the tool is not going to work. So you can say that will represent a tool life. So that's why the number of holes I am representing it as a T1, that is equal to 150. Okay, and corresponding to that speed N1 is equal to 200 rpm I am taking. This is the first data. If the drill speed is increases to 300, so speed is increases to 300, N2 is equal to 300 rpm, then it can produce 60 through holes. So if speed increases, the number of holes are going to be reduced, lifespan is going to reduce, so that 60. Okay, now 60 holes only we can make. Right, assume all other parameters remains constant. Assume all other parameters remain constant. So here you can take generally Taylor's tool life equation, Vt power n equal to constant. So some of you people think that time is not given like that, tool life is not given like that. But here tool life is nothing but we are considering the number of holes only, because the maximum tool life we can make 150 holes for the first case and 60 holes for the second case. So I can write it as speed into T power n is equal to constant. Okay, now you can solve it. Here see here N1 T1 power n is equal to N2 T2 power n. N1 is 200, okay, into T1 is equal to 150 power n is equal to N2 is 300 into T2 is 60 power n. Right, by solving this question you will get the n value nearly 0.44. N value is nearly 0.44 you will get. right? So these are the questions from the production. And one more question from the deep drawing I already discussed. One material science question also already discussed.
Yes. Yes. Dear students, for this question, since the properties, table of properties are not printed, that's why I thought that this question is asking whether the liquid level is increasing or decreasing. So based on that consideration, I concluded the liquid level decreases. But the question is properties, table of properties are given for water. So with that we can decide how much length of the liquid level is decreasing. Let me read the question once again. A rigid closed vertical cylinder vessel of 15 centimeters diameter. Diameter of the cylinder D given 15 centimeters means 0.15 meters. Contains 5 kg of water. Mass of the water given 5 kilograms. At 80 degrees centigrade. Initial temperature is 80 degrees centigrade and 10% quality. That means at 80 degrees centigrade, at T1 equal to, that is the saturation temperature, 80 degrees centigrade, the dryness fraction X1 is given, quality given 10% means 0.1. Okay, next. The water is heated till its temperature reaches to 130 degrees centigrade. At Tsat 2 or T2, that is 130 degrees centigrade, 130 degrees centigrade, considering only a horizontal separated interference between the liquid and vapor, the drop in the liquid level after the heating process is, he is asking what is the decrease in liquid level. Properties of the water at various saturation temperature are to be used, right? That property is not mentioned or not printed here. That's why I thought that only it is asking to decide whether the liquid level is increasing or decreasing. But right, so since the properties are given in the problem, you can decide how much length, how much level of the water in the container decreases. For that, initial specific volume of the saturated liquid corresponding to 80 degrees centigrade and VFG1, these two values are 0.001029 and VFG1 3.4042 with respect to units, that is meter cube per kg. Similarly, at state 2, that is corresponding to saturated temperature 130 degrees centigrade, the specific volume of the saturated liquid VF2 0.001070 and VFG2, if VG2 is given, you know VG equal to VF plus VFG. From this you can decide VFG, the VFG equal to VG minus VF. So from that you can decide the VFG2 by known VG2 and VF2. It is 0.667, both are in meter cube per kg. Since it is heated in a rigid closed vessel, means volume remains constant. Volume remains constant means initial volume of the wet vapor equal to final volume of the wet vapor. Initial volume of the wet vapor Vf1 plus x1 into Vfg1. It is equal to, right, final specific volume, that is corresponding to 130 degree centigrade, Vf2 plus x2 into Vfg2. You substitute the Vf1, Vfg1, x1, Vf2, Vfg2 for finding the x2 value. You simplify it for getting the x2 value. My calculator has shown the x2 value 0.5102. That is the final dryness fraction. Then, as you know, specific volume of the liquid equal to volume of the liquid divided by mass of the liquid. Then initial specific volume of the saturated liquid Vf1 equal to, I can say, VL1, initial volume of the liquid divided by initial mass of the liquid. From this you can decide that the initial volume of the liquid equal to saturated liquid volume at state 1, that is corresponding to 80 degree centigrade, multiplied by initial mass of the liquid. But you know, mass of the water given, how much it is? 5 kilograms. Then initial mass of the liquid with dryness fraction 0.1 equal to mass of the water into 1 minus x1. Initial mass of the water is 5 kilograms. 1 minus 0.1. You simplify this value for getting initial mass of the liquid. It is 4.5 kilograms. 4.5 kilograms. Then initial volume of the liquid VL1 equal to, right, Vf1 is 0.001029 multiplied by initial mass of the liquid in the wet vapor 4.5. You simplify this value for getting the initial volume of the liquid, right? My calculator has shown 0.00463 meter cube. This volume of the liquid must be equal to, right, since it is given cylindrical vessel, area of cross section multiplied by length of the liquid. Then length of the liquid equal to initial volume of the liquid divided by area of the cross section. Right? It is equal to initial volume of the liquid divided by pi by 4 into d square. This d should be in meters. Let us take another slide. Initial level of the liquid equal to VL1 divided by pi by 4 into d square. Here initial volume of the liquid is 0.00463. 0.00463 divided by pi by 4 into d is given 15 centimeters, but it should be taken in meters. 0.15 meters. 0.15 meters whole square. You simplify this value for getting the initial level of the liquid. My calculator has shown 0.262 meters. That is equal to 26.2 centimeters because options are asking in centimeters. Next. Similarly, right, you need to decide the final volume of the liquid. Right, for getting the final volume of the liquid, VL2, final volume of the liquid equal to initial volume of the liquid Vf1 into ml1, final volume of the liquid Vf2 into final mass of the liquid at 130 degrees centigrade, Vf2 into mf2 equal to mass of the water into 1 minus x2. 1 minus x2. Right, Vf2 value 0.00107, 0.00107, mass of the water is 5, 1 minus, look at the x2 value, x2 value 0.5102, 0.5102. You simplify this value for getting the final volume of the liquid. My calculator has shown 0.00263 meter cube. That is the final volume of the liquid. Look at the initial volume. Look at the initial volume. Right. So, right. This is the stuck in the it's stuck. 1 minute. It's stuck. Sorry for the inconvenience because of the overheating. This fellow is stuck, right? Anyhow, this is the VL2. This VL2 volume of the liquid equal to pi by 4 into d square, diameter remains same, into L2. From this L2 equal to VL2 divided by pi by 4 into d square. VL2 value 0.00263 dividing by pi by 4 into d value given 0.15 whole square. You simplify this value for getting final level of the water. Here it is 0.148 meters. This is the initial level of the liquid, 0.26, final level of the liquid, definitely liquid level decreases. Then decrease in liquid level. Decrease in liquid level equal to initial level of the liquid minus final level of the liquid. Initial level of the liquid is 0.261. It can be written as 26.1 centimeters, and this is the 14.8 centimeters. Therefore, the change in length 26.1 minus final length is 14.8. You simplify this value for getting the answer. My calculator has shown, here it is shown 11.4 centimeters. 11.4 centimeters. This is the answer. That is the decrease in length of the water level by the time the water is heated, or two-phase mixture is heated with a volume more than, with initial volume more than critical volume. Understood clearly? Yes.
Last but not least, from the general aptitude, we are getting 2 questions from the memory based. Okay, let's see the question. So log x base 2, log x base root 2. Base root 2 already know, so power 1. So 1 by 2, that means 2. So it is 3 log x base 2 is equal to 48, 3/16. So x power 2 power 16 is equal to x. So option A. Next. And 2 students from the engineering school and 3 students. A student council of the 10 members of consist of 2 students from the engineering school, 3 students science school, and 5 students art school. Overall 10 students. So denominator we need 3 members, 10C3. Okay, 10C3. And 2 students, 3 students, 2, 3, 5. Okay, 2, 3 and 5. And 2 students compulsory same branch. Okay, so from these 2 you can take a completely 2, and remaining person 1 person, 8C1. This one 3C2, 7C1. Here 5C2, the remaining persons 5. So 5C1. You can simplify the answer. It become 79 by 120. Option D, here not available. Okay, so option D, 79 by 120 is the answer. These two questions from the memory based from the students. Okay, so exact paper, exact question and solutions as early as possible after releasing the papers, we are getting answers. Thank you. All the best, my dear friends. Thank you.